Welcome, ladies and gentlemen, to this video. Today I wish to make a vlog about the progress I've made in designing a piano mechanism that is 3D printable. Now, this project is really fascinating to me because I'm trying to solve an issue that I have when I play the piano, where when I try to make a military rhythm that has like a repeating sound like I get the issue that the key bounce doesn't happen fast enough for me to manifest my musical idea. And so that's a problem that was addressed in the 18th century, from what I gather, if it was from the company Pleyel that created the double escapement mechanism, and thus enabling the piano key to reset much faster after a hit. Now I've got the piano assembly here on the background. You can see we're going to go through the different parts in a second. So I started here, made some research about the different parts. I'm going to take that out. Okay, so you can see here the different parts of the piano. Now the important parts are the knuckle, the jack, and the whipping. And there's the capstan also. The other part that's really important is the lever arc. So this little piece here, that's really important. And then there's some weight here that you can add, or there's a hammer. There's the back check here that catches the hammer, and there's multiple different pieces of felt so that the piano mechanism is a little bit more muted. Now there's also the damper on top here and this damper lever. Now this part here I did not tackle yet. That's going to happen at a later point. My focus for the minute is really to optimize the hammer, knuckle, jack, whipping, capstan assembly. So I want to focus on these parts over here. Those ones I'll go at it at the point later on. So the first step, I did record this video of me drafting, by the way. I didn't upload it because my internet connection isn't so good. But I've recorded me drawing this, and so I'll show you the drawings that I have. The first drawing is right here. Okay, so I made this drawing using the grease pencil. I was trying to identify the key aspects and key parts to elevate. So my original idea was to embed a spring at the bottom of the key here, so to bring the key back up, and then use magnets in order to move and propel the hammer around. And so I have a big square here because that part I wasn't too sure how to deal with, since the original jack and knuckle system is designed like this. The jack here is utilizing this little rest in order to slide off of the knuckle and let the hammer reset. That makes it so that the hammer does not stay on the string and mutes the sound. By having this knuckle and jack that slides off because of this stop, the hammer is then released from tension and returns to rest. So this part here I put it into a square because I thought I might not be able to require this part since I'm utilizing magnets. That's the purple. I might be able to go around it, so I wasn't too sure. That's more like a question mark over here. Then I did try to design some cool looking part, maybe a key that has characteristic shape, so to recognize the piano at rest, or the mechanism involved. The other thing that's really important here, and that's one of the major key, I have a few different major improvements that I'm working on, but the first one is the knuckle and jack. Now if you look at the knuckle and jack over here, you'll see that this is a rather simple shape, right? It's like a wooden piece, a wooden circle, and then there's the jack that leans on it and then slides off. The thing is, when you consider this assembly, this was made using primitive tool. And what I mean by that is that in the 1800s, when these mechanisms were designed, the tools they had access to was a sharp blade and a piece of wood. And they had to carve that shape to the right perfect shape, and so to create the right mechanism. And that was the optimal setup that they can dream of. The difference is now we've got 3D printing, so I can use parametric modeling and splines in order to create the perfect knuckle shape and the perfect jack shape. And so I can have a much higher atonement to the nature of that curve on the knuckle. I can have a sharper knuckle, I can have a shallower knuckle, and I can have a lot of control on how the interaction between the jack and knuckle happens through simply the shape. So just by drawing the right geometry, I can change its control or maneuver in space. Okay, so I decided to have this hammer with a more exotic shape. But the more important part here is you see this connection point of the knuckle and jack. There is no independent knuckle, as you can see here. The knuckle's an independent piece. Here, it's part of the design of the hammer. So that curve here is not just added. This one can be manipulated and changed so to suit the style of the player, say. So I thought, okay, I'm gonna start with this and go forward. So then I jumped into Fusion 360. I imported my sketch, and I started to draw this to realize it in a 3D printable fashion. Now this is version 2 that you see here. Version 1 was not really good. It was more about calibration print. I do have the mechanism here, but it's not really good. It was just to set the right parts. Just find the ballpark for different positions of objects. Now this, the one you're seeing here, that is version 3. So I made some significant improvement on the weapon, on the jack, and on the capstan. So since my objective is to utilize magnets in order to hasten the movement of the hammer and stabilize it, then I decided to create this capstan crew mechanism that is inside of the weapon instead of the base of the weapon. So here, this one is mounted on a screw, so I'm going to just take the weapon out for a second. So this is on a screw here. So you can see here that this pin screw can connect to an axial connection with the weapon by just connecting a pole. And then as I connect that, then I can change the position of that screw. I can put it here or here. I can put an angle on the magnet so to change the feel or pull of it. And I can also adjust the height of this object by screwing it up or down. So that makes for a lot of control on the position of the magnet. Now the hammer here also has a magnet cavity right here, and it has a magnet cavity over here. So these are the magnets that are in, well, this one here is the magnet that interacts with the capstan screw. Now in the test that I've done so far, when there's a pull between the capstan screw and this magnet cavity, it creates the best outcome. So it really brings the hammer back down to a stable position really effectively. And then I also have another magnet here, which is at the end of the key lever that is acting on a cavity in the, or another magnet in the hammer. And those two magnets here, those are repulsion magnets. And so this one pushes the magnet while this one pulls it down. The thing is, the pull of the magnet is so powerful that I need some counterweight in order to balance the actions of the magnet. But yeah, so as the key is pressed, then that's going to push this magnet field up and out of this capstan screw pull. Now there's also this other piece here, which also has a magnet cavity inside here. A little bit harder to see. But there's also a magnet here that's also a push magnet, and this is a magnetic backstop. So as the hammer is pushed up, it's gonna lift this flap, and then the magnet here is gonna align with this circle or this cavity, and it's going to have a repulsive push. And so as the hammer goes up, it encounters this counteracting magnetic field and then goes back down. Now I think that's a much better way to utilize to make the piano mechanism, because that see, on the old mechanism, in order for the hammer to reset, the jack has to slip outside of the knuckle, and thereby gravity can bring the hammer down, and then it's going to be catched with this soft spring here and the felt on that object on that backstop or back check, and so by having it tilt and have the friction, it's going to catch the hammer. But friction and this spring to me is a lot less effective than a well-placed magnet, because the magnet's going to pull and have a very strong pull. And so I don't really need to have a suspension. I can just pull the magnet and make sure that the field is not too powerful. And then it's going to have a much stable return. And also, as the knuckle change shape, I can use a magnetic push to bring it back faster than simply gravity. Now, this being said, the forces that are part of this object are going to change wildly from this original setup, because now that I use magnets and more precise jack shapes, I'm able to generate a lot more energy than just this basic mechanism. And so I can have a hammer that's maybe 3 or 4 times the weight, and it's not going to make a big difference because the feel is going to change according to the weight, but the mechanism is going to function just as well, because the magnets are going to enable me to move more material or matter or weight around in this mechanism. And so if I go back here and I look at the profile of the whipping and jack, the hammer and jack, so you can see here that the shape for the knuckle is a lot different, right? And then the jack over here, which does not have the tail right here. So this tail here that makes the jack move, that's not necessary in this mechanism, because the backstop here and just the shape of the cavity deals with that effectively. And so here I can change this again according to this lattice, so I can have different angles for that jack depending on what I want. And then that whole curve here is going to translate the movement of the key forward to the hammer in a very efficient way. Now also, because of this shape, as the hammer is pulled up, then only a small piece of this jack is going to contact over here, and the energy is going to be so weak that any opposite force is going to win, right? So it's like naturally kind of pushing itself out of the way for the backstop to kick the hammer back in place, or for the magnetic bounce to return the hammer, right? So this is designed so that it moves out of the way naturally without the need for any other mechanical input. So this is a big step forward in terms of the mechanism in my eyes. Now, I did use this lattice here. So this is part of the second model, this hexagonal lattice connection point. It helps me to have more control on the different position and clearances and tolerances of the part, which I thought was interesting. Now, since the frame is starting to solidify in its functionality and position, I decided to add an aesthetic quality to it, which is over here. So now I redesigned the frame so that it has this more heightened aesthetic quality to it. Where you can see here there's an angel playing the guitar that holds the same lattice design, but with a little bit more of artistic attention and detail. And also have here a big difference between the number 3 version and the number 4 version, or version number 4, is that I have this base to the system. Now, why is this base present? I was thinking about the ways I could improve the piano mechanism, and one of the ways I thought I should improve it, that's really specific to 3D printing in some sense, is that I can, instead of having a fixed lever arc profile, I could instead put a lever arc wheel and thereby change the play profile of the key according to the position of the wheel. So here what I have is this wheel here. Let's just isolate that. So this wheel here, hold on. You can see that the profile, its outline has different characteristics. It has a sharp end here or a higher end here. And so as you spin it, you'll either have a lever that has a peak at near the hammer or a peak near the key lever. And so you can change the balance of the key dynamically. Eventually it's going to be possible to mutate that according to settings and controls, but for now it's just a bunch of different static positions that I can choose by rotating this piece, which is not part of any other piano mechanism. It makes it unique to 3D printing in some sense. So that's really interesting. Now I also set a few different axes inside of this frame because I want to try a few different setups for different types of lever arcs. Some of them I'm looking for a design that's really hard to define, but it looks like a neo-futuristic prism that's going to be horizontal underneath there, and that's going to have the ability to mutate. Instead of spin, it's going to change shape, but that's a complicated thing. It's going to happen later on. For the minute, I still have many different things to figure out about this mechanism. But still, you can see here that there's a lot of progress that's being made in the quality of the object, and I'm trying to rethink and enhance the potentialities of all the parts by utilizing 3D drafting and modeling. Because I think that in the time where the piano key mechanism was designed, they had a very limited means of production, and thereby the outputs that they ended up with in creating the piano mechanism is deficient according to what is possible today. Meaning that what is traditionally a stable design quality of the piano mechanism, when I look at it today with the means of production, I'm like, I see a few different missing parts that could be enhanced boldly by utilizing different systems. Now, this one here, I just wanted to use this frame in order to enhance the mechanism. Now, you can see also the key, it just got improved. I've got this capstan spinning axis thing. There's a bunch of different parts that got improved on this mechanism, which is, I think, really nice, but I still have more work to do. Now I'm working on a system to add pulleys inside of this mechanism, because I think if I use strings, I can both create a new sense of multiplication of force, meaning that a light touch can create a powerful output. And I can, I think, also add different qualities to the key, meaning that moving the key forward and backward might be able to create a variation in the sound by changing perhaps the position of the hammer dynamically, or something like that. But I need to do a lot of testing with the pulley mechanisms before I can figure out the right way to do it. So that led me to develop a bunch of different things, which I think is interesting. See, trying to solve this piano thing led me to try a bunch of different geometry setup, or it forced me to solve other issues that are more universal, like this one here. Which this one is a prism that is used in order to create any shape of pulley mechanism. So I can create an advancement of all these different parts and create a structure and then have pulleys on that structure. But I needed to have a kind of a basic prism so I can create the pulley mechanism. And so it forced me to develop something like this, which I think is really interesting. You can do a lot of things with this. This is like a universal Lego block, but that one I made it so I can test the different potentialities of that piano mechanism. Anyways, so that's the progress I did in the Vastalery piano mechanism. This is going to be a masterpiece. I want to let you know that, because that's exactly what I'm aiming for. But it's not there yet. That's going to take most likely years in order to manifest fully. I just wanted to share some of the progress that I've been making. I'm still working on it. I've been printing parts for days now, trying to get this together. Because with the pulley assembly, we're looking at an assembly of more than 40, maybe to 100 parts. So it's going to be much more complicated than a standard piano key, but it's also really interesting because it might lead to unexpected breakthroughs, much like this T-slot thing, which is amazing. I can use this to make anything. It's really cool. So anyways, that is going to be it for the progress that I made in the piano mechanism. So that's what I wanted to go through with you today. So thanks for watching, and I'll see you guys soon.